Okay, so this is just going to be an introduction of how we get the double angle formula. So in the syllabus it talks about how we need to derive the double angle formula. So that's what we'll do in this video. So we're going to learn how to find trigonometric double angle formulas, and that's using the compound formulas that hopefully we've used before. So it would be like a previous lesson. Okay, so we've got our compound angle formulas from the formula sheet, and now we're going to use a double angle formula. So I'm going to start with this first one, and I'm just going to substitute in theta for both of them. So I'm going to go, instead of sine A and sine B, I'm going to put theta and theta. Okay, so what's theta plus theta? It will be 2 theta, so that means it's going to be double theta, so hence the double angle formula. So I'm going to go sine theta plus theta equals sine theta cos theta plus cos theta sine theta. So what ends up happening is that we have two lots of sine and cos. So therefore sine 2 theta actually equals 2 sine theta cos theta. Now this is actually a very important identity, so make sure you put a box around it in your notes. Now we're going to do the same thing for cos. Okay, let's do it for cos. So we're going to go cos, and I'm just going to write it straight out as 2 theta. So what I'm replacing is same thing, theta for all of them. Okay, so it's going to be cos theta minus sine theta sine theta. So what's cos theta times cos theta? Well, it'll be cos squared theta minus sine squared theta. Now this ends up becoming, so that's what cos 2 theta is, a very important identity as well. So make sure that we put really good boxes around it. Okay, so the final one we're going to do is the tan one. So let's go tan 2 theta equals tan theta plus tan theta over 1 minus tan theta times tan theta. So we can simplify that out to be there's two lots of tan theta at the top, and that it's going to be 1 minus tan squared theta. So that's what tan 2 theta will equal. So here are the 3 double angle formulas that we'll need to use. Now these are identities. We're going to use them in the same way that we use like sine squared x plus cos squared x equals 1, and we replace it. We're going to do exactly the same thing. Okay? Alright, so that's your double angle formulas. That's 1, 2, 3. Now there's something that we can do more like it. So I will show you. I'm going to use the cos one. So the cos 2 theta equals cos squared theta minus sine squared theta. Okay, and that's simply from here. Now this identity gives us a few more identities that you can see in the formula sheet down here. So I'm going to show you how we get them and the process towards it, because at every step there's an opportunity to do an identity. Okay, so I'm going to start with my Pythagorean identity, and that's just sine squared theta plus cos squared theta equals 1. Now that means that I can go cos squared theta equals 1 minus sine squared theta just by minusing sine squared theta from both sides. Okay, so that's one identity I'm going to use. And the second one will be that sine squared theta. So I'm going to use the same process, except I'm going to minus the cos equals 1 minus cos squared theta. If you don't get what I've done there, then you need to work on your identities, because it should be pretty straightforward for now. Okay, so what I'm going to do is I'm going to rewrite this cos 2 theta out here, and now I'm going to substitute in for sine squared theta. I'm going to make everything cos. So minus, so instead of sine, I can use this one. So I'm going to go 1 minus cos squared theta. And what happens is that if I ski jump here, that will become, the cos theta will become positive. So I end up getting 2 cos squared theta minus 1, and that is equal to cos 2 theta. A very important identity this one is. Okay, very important identity. Now from that, we actually get this guy down here. So what we'll do, I'll show you how we get it. So this is in the formula sheet, this one, formula sheet. So what we'll do is that we'll make cos squared the subject. So I'm going to make cos squared theta the subject. So that means I've moved this 1 across, and I've moved the 2, I've divided it by 2. So I'm going to do it in one step. I'm going to go cos 2 theta plus 1 divided by 2. Okay? And all they've done here is that they've put the 1 at the front, and they've put the half out the front as well. So 1 plus cos 2 theta. Okay? All right. Please pause if you need to, but what I'm going to do is I'm going to get this sine one happening. So I am going to rub everything off from here to get the second identity happening. So I'm going to use a bigger rubber. There we go. All right, so instead of replacing sine, I'm going to replace cos. So I can go 1 minus sine squared theta minus sine squared theta. Now, what happens is I'll end up having 1 minus 2 lots of sine squared theta. So that's what cos 2 theta is. And so now this is an identity in itself. Now let's make sine squared the subject, just like we did in the other one. So I'm going to go sine, so I'm going to flip these two around, and then I'm going to divide by 2. So I'm going to have sine squared theta equals 1 minus cos 2 theta divided by 2. And you can see the same processes happening with the other one. And we've got 1 minus cos 2 theta, which actually happens to be exactly the same as what you got in your formula sheet over there in the, you get the same thing in the formula sheet. All right, hopefully that explains it all. You'll have to use, in your exercise, you'll have to use every single one of these steps to do an identity, and these ones as well. Peace out.